Okay, today we're going to be diving into Unit 2 this year, and we're going to start looking at our exponents and squares and square roots. So today we're going to be solving square root equations. This is going to be a little bit different than the last video where we were just solving square roots. Now we're going to take that and apply it to algebraic equations. Um, Today we're going to start with calculators, but eventually we will move into how to doing it without calculators. So let's get started. Just a little refresher. Hopefully you remember how to find the square roots of perfect squares um, and how we discussed that it is the opposite of squaring a number. So if you take the square root of 25, what we're really trying to find is the square root of what number times itself, and the only number that we can plug in there is 5, because 5 times itself gives us 25. And so now the square root of 25, we pull one of those out, and we're going to get is 5. The square root of 81, again, we're saying what number times itself gives us 81, and that would be 9 times 9 is 81, so we pull 1 out, square root of 81 is 9. So another way to see this then is the square root of 25 equals the square root of 5 to the second power. Because when we write 5 times 5, that's just the same as writing 5 to the second power. And then we get 5. And so what we really need to be able to see today with solving square root of equations is that when we take the square root of a square like that those two are opposites. It's no different than if addition being the opposite of subtraction and multiplication being the opposite of division. Square rooting a number is going to be the opposite of taking a number squared. Okay? So if we look at this with 81, the square root of 81 is going to equal the square root of 9 to the second power, because 9 to the second power is 81. And these two kind of cancel each other, and we're left with 9. So again, it's important to realize that squaring a number and taking the square root are the opposites. If we start with 8 and we square it, we get 64. If we then take the square root of 64, we end back with 8. So we started where, or we ended where we started with the same thing, because squaring a number and square rooting a number are opposites. They kind of undo each other. It's no different than if I started with 5 and I added 2, I would get 7. Then if I subtracted 2, I'm back to 5. Again, the adding 2 and the subtracting 2 undo each other, so we end with the exact same thing. If I take 5 times 2, I get 10. And if I divide it by 2, again, get 5. So the multiplying by 2 and the dividing by 2, again, they're opposites, so they undo each other. Same thing with the squares and the square root. If I take 5 to the second power, I get 25. If I then take the square root of 25, I'm back at 5. So taking the square root and squaring a number, those are opposites, so we're again left with the same number. Now that we know they're opposites, we're going to take that and apply it to algebraic equations in solving algebraic equations. What you should remember in the past is how to solve algebraic simple one-step equations. The way you did it in the past is typically you drew a line that separated this is side 1 versus side 2, and we need to get x all by itself, which means we need to get rid of this 6 or this plus 6. The way we get rid of this positive 6 is by subtracting 6 or doing the opposite. The opposite of addition was subtraction. We subtracted by 6. They cancel. We're left with x. Because 6 minus 6 is 0. That's why they cancel. X is left all by itself. And then 5 minus 6 gives us negative 1. We now solve that equation. If I look at another example, again, whoops, let's try to draw a better line than that. We'll divide it into two sides. This time, y is paired with a minus 4, so I'm going to add 4 to both sides. Minus 4 plus 4. negative 4 plus 4 gives us 0, so we're left with our y. And then 10 plus 4 gives us 14. So again, this should be review. You should have been able to solve one and two-step equations without a problem. Today we're not going to be doing that. Today we're going to be taking that and applying it to squares. Okay? And so the whole goal of, if we flip back, the whole goal here was to do the opposite operation and that isolated x to be all by itself. And once x was all by itself, we were able to solve the equation for x and find a solution. Same thing here. We need x to be all by itself, except this time, instead of x having a number added to it, we see that it's to the second power. So since it's being squared, we have to do the opposite. The opposite of squaring a number is taking the square root. Okay? Our rules of algebra say what you do to one side, you do the same thing to the other side. So now the square and the square root, they actually cancel each other out, and we're left with x. The square root of 49 is the same as what number times itself, which means 7. So then we actually get x equals 7. When we look at y squared, again, our variable is not alone. It has to the second power, so we have to do the opposite, which is square rooting. Y, the square root of y squared, those cancel each other out. We're left with y equals the square root of some number times itself. So I have to ask myself, what number times itself gives us 144? The answer is 12. So I pull one of those out. The square root of 144 is 12. And then finally, our last problem. This time the variable is on the right side, but it doesn't change anything. We still have it being squared, so we have to square root, because that's the opposite of squaring a number. We're left with b, and the square root of 100 is 10. Now, for a side note, we can always double check our work. So if I look at this original problem, it was the x to the second power equals 49. So we're saying what number to the second power equals 49? What we found was 7. So let's try plugging 7 in to the second power, and we can double check. 7 times 7 gives us 49. So we ask ourselves, does 49 equal 49? We say yes, and so our answer has to be right. Same thing with this one. We write out the original problem. We get y to the second power equals 144. So we're saying what number to the second power? Well, we found out that 12 to the second power equals 144. So 12 times 12 would give us 144, and indeed it does check out, because 144 equals 144, so we know our answer is correct. Okay. Okay, so that's it for today. I hope this helps with solving square roots and equations.